Now children, in this video we will study about the metallic and non-metallic character. Metallic character means the characters shown by metals. Now what are metals? Electropositive elements are called metals. Means nothing but in a way electropositivity, that is metallic character. Similarly, non-metallic character means the characters shown by non-metals. What are non-metals? Non-metals are the elements which are electronegative in nature. Right? So in a way nothing but you can say electronegativity. So in a period we know left to right, we all know children. Non-metallic character increases and the metallic character decreases. Top to bottom in a group, non-metallic character decreases and the metallic character increases. This way metallic decreases, this way increases. And in a period, non-metallic increases and non-metallic decreases. These points are there. In a group, top to bottom, non-metallic character, top to bottom, decreases and metallic character increases. Then in a group, top to bottom, the basic nature of oxides and hydroxides increases. Prior to that, you should know what elements form what type of oxides. The point says metals form basic oxides and non-metals form acidic oxides. Okay? Metals form basic oxides while non-metals form acidic oxides. Now, since in the group top to bottom metallic character increases, so the oxides of metals, we know they are basic, so basic nature of those oxides will also increase. I repeat, top to bottom in a group metallic character increases. One point. Second, we know metals form basic oxides. So when metallic character is increasing, the oxides formed by them will be more and more basic in nature. So in a group top to bottom, basic nature of oxides increases and oxides plus water they make hydroxides. So the point is basic nature of oxides and hydroxides increases. Right? Then it is in a group top to bottom, acidic nature of oxides decreases. You learn for one opposite, you can easily relate yourself. When this way basic nature of oxides increases, obviously acidic nature will decrease. This way acidic character increases, so obviously basic character will decrease. Now, the question, in a period, as I told you, in a period left to right, acidic nature of oxides increases and basic nature decreases. Children, learn for one. Top to bottom, metallic character increases. So the oxides formed by them, they'll be more and more basic in nature. Reason, metals form basic oxides. Left to right, non-metallic character increases. One fact. Second, we know they form acidic oxides. Hence, the acidic nature of oxides will be increasing this way. If increasing this way, it will be decreasing this way. What decreasing? Acidic nature. Now the questions. You are given lithium oxide, sodium, potassium oxide and rubidium oxide. Which out of these will be most basic in nature? So we have learned, first we know that these all are metallic oxides, one thing. Then I can see they are from the same group top to bottom. Top to bottom we know metallic character increases and we know metals form basic oxides. So the basic nature of oxides will also increase. Hence, rubidium oxide will be the most basic in nature and this will be the least basic in nature. Similarly, come to question number 2. N2O5 and P2O5. We know that these are the oxides of non-metals. One thing. Second, we know that non-metals form acidic oxides. Fine. Question is, which out of these two will be more acidic? So they both are non-metallic oxides. They will be acidic in nature. Then they are from the same group. Top to bottom, I know in a group top to bottom, basic nature of oxides increases and acidic nature of oxides decreases. So naturally P is below, N is above. So naturally N2O5 will be more acidic in nature. Now we are moving in a period. I have taken the elements of children third period. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, they're oxides. We know in moving left to right, the acidic nature of these oxides will be increasing, certainly. Now children, this will be most basic in nature. Then this is basic in nature but not as basic as it was there. Now this is aluminium oxide. I think you know from class 8 or 9th, and you have some idea from 10th also, we have commonly three metals: Al, Zn, Pb. Aluminium, I should write, aluminium, Zn and Pb. Their oxides are amphoteric in nature, means they show acidic as well as basic nature, and that's why we call them amphoteric metals. So oxide of this aluminium is amphoteric. It shows some properties of acidic oxides and some properties of basic oxides, or you say to some extent it can behave like metallic oxides, and to some extent it can behave like non-metallic oxides. Somewhere behaves as basic oxides, somewhere behaves as acidic oxide. Now come to these: silicon, phosphorus, sulfur, chlorine. We know they all are purely non-metals. Fine. So as we are moving left to right, the acidic nature of oxide has to increase in a period L2R. Acidic nature of oxides increases. It should be increasing, certainly. So after amphoteric, this will be Wa. Wa means weakly acidic. Then P2O5, acidic. SO3, strongly acidic. And Cl2O3, very, very strongly acidic, right? I can even write very strongly acidic, right? That's how, children, it goes this way. So left to right, when you move in a period, the acidic nature of oxides increases. In between we had, like in third period, aluminium oxide, which was amphoteric in nature. For your information, children, there are some non-metals which form neutral oxides also. Like I'll tell you, we have N2O and NO. These are neutral oxides, right? And some other neutral oxides are like H2O and CO. These are also neutral oxides. So these are non-metallic oxides but neutral oxides. And your Al2O3 as well as oxides of Zn and Pb, they are also amphoteric in nature. This was all about your nature of oxides. Just remember 2 points, children. This way metallic character increases, and this way non-metallic character increases. One thing. Second is, metals form basic oxides and non-metals form acidic oxides. This point you should know. Metals form basic oxides and non-metals form acidic oxides. This much if you know, everything can be done. In a period, this way metallic character increases, this point, and in a group top to bottom, non-metallic character decreases. So whichever way you want to learn, you can see, and then they can ask you the questions of oxide. Similarly, if they ask us, they are giving us lithium hydroxide, potassium hydroxide, and say sodium hydroxide, and they're giving us potassium hydroxide. This will be the increasing order of their basic character. Okay, basic character. So their oxides and hydroxides, if you move top to bottom in a group, their basic character increases, and this way acidic character increases. So this was all about your metallic and non-metallic character and the nature of oxides. So this is all for today, children. We stop here. You will revise and update your notes. This is all for today. Hope it is clear to you all. This is all for today. Thank you.